Hello and welcome. Today we are going to discuss the different architectures and topologies of application that can be deployed on Platform.sh PaaS. This session was initially run at Platform.sh Evolve Partner Summit last October. We will start by a brief reminder of the main application architectures. We will then see the multiple ways of deploying those on Platform.sh, and we'll take a look at some real customer use cases to illustrate that. Finally, we'll peek into what we, as Platform.sh, deploy on our own PaaS. So let's get started and look at those architectures. What is a monolith? It is a single application that does everything needed. It is usually simpler to develop, test, and deploy as it's a single code base. Because it has less moving parts, the operational complexity at infrastructure level is usually lower and makes it easier to scale as it works as a single block. Now let's talk about headless. This architecture provides more flexibility as the backend and frontend are split. We can also see scenarios where there are multiple frontends for a single backend, or even multiple backends for a single frontend, making it easier to address the different scenarios you may face. This split requires a lower effort when a technology needs to be replaced. The scalability also gets more granular as you can scale either the front end or the back end, depending on where the load is happening. Ultimately, this architecture permits to move faster and reduce possible technological debt. Microservices is considered the more modular approach. In this sense, it provides with a faster pace to develop, as each microservice can be handled separately. In this architecture, you only scale what's needed, and usually it's considered more resilient as, in most cases, one microservice downtime doesn't necessarily mean a global outage. One of its major advantage is the ability to use the technology that better fits to the need of each microservice independently of the one used on the other microservices. Now, what we've seen over the past few years is a steep increase in complexity, even when it's not necessarily needed. And one of the main message we are trying to share with our partners is to aim to keep things as simple as possible. For instance, a microservice architecture isn't needed for a corporate website. And in most cases, even headless may be a bit overkill. Try to keep it simple. It's almost always the best way to go. Okay, now that we've reminded ourselves of this architecture, let's take a look at how these can be deployed on Platform.sh, starting with our friend, the monolith. As stated previously, a monolith is a single code base. As such, there is really only one way to deploy it, through a single Git repository and to a single Platform.sh project. This is a timeless classic. A headless project can also be deployed through a single Git repository and to a single project. In that case, everything gets deployed at the same time, and this provides both code bases with potential access to all the services deployed within the project. This also means that both applications will share the same environments and will split the resources available, which can sometimes make scaling a little bit more difficult. From time to time, we hear that the front-end and back-end developers may not want to work within a single Git repository. And there's a little trick that can help you. You can use Git submodules to unify multiple repositories into a single one. and use a common platform message plane to deploy the project. But a headless project can also be split into two different Git repositories and be deployed to two separate platform message projects. This is particularly useful if, for instance, a new version of the backend needs to be available at the front-end build time. This approach provides a more granular deployment strategy and potentially a better approach to scaling, meaning that you can use smaller plans to start and only scale for the application that needs it. In this scenario, the services are then only available to the backend. Keep that in mind if, for instance, they need to share a Redis instance. Now, a microservices based architecture can be deployed as well within a single platform message project. It would present the same functioning as the similar use case for the headless one. This is particularly interesting approach if the resources needed are low or if all microservices need a direct access to the same services, like the database one, for instance. This scenario also implies that a deployment could affect all microservices. Keeping that in mind, it should be used with caution depending on the way they interact with each other. But we can also have an approach where multiple Git repositories are used for the microservices. In this scenario, you can even mix some microservices within a single project, for instance, if they need a direct access to some shared services, while isolating completely the other ones. Although this diagram may seem a more complex, it's not really. This is just about using Platform SH at scale to manage a fleet of microservices. They will interact between themselves only through API or HTTP calls, making them completely independent from one another. Very well. So that was the theory. Now, let's take a look at some real customers and the usage they have of our cloud application platform. Let's start with the monolith, right? One application, four services, a single Git repository, which deploy everything, making your life way easier. As said previously, this is a timeless classic and straight to the point. But we can also reach this level of complexity with Platform Message. This is an API first and microservices project. This customer decided to deploy everything within a single Platform Message project because all the microservices and APIs were in some way or another sharing direct access to some of the services, that being MongoDB or PostgreSQL or Redis or even the storage. As you can see, it also leverages our workers feature to handle some of the asynchronous tasks. This is a very interesting usage of our product, as this is one of the first complex microservices we've seen deployed. This is also a microservice and headless application. The e-commerce backend is running Magento, and the CMS backend is on Strapi. We also have a microservice using Core.js, and all of those are beyond an Next.js frontend. This customer uses four Git repositories and four different platform message projects, as none of these bricks were in need of sharing any services. All their interactions is done through HTTP, and all the microservices and the backends are basically isolated from one another and don't contact each other. Everything is done through the front end. This is a very elegant use of our platform while limiting the possibly unwanted interaction within each application deployed. But we can also add some more stuff into that. One of the other use that we can share today is this microservice architecture mixing a lot of technologies. A services backend running multiple Java applications and a CMS backend running Drupal. Both applications are behind an API gateway using Apollo, and everything is served through a Next.js frontend. This is as well 4 Git repositories, 4 Platform.sh projects, permitting to isolate each application within their own scope. We can well imagine a switch of technology on any layer at any time. Testing on non-production environments is done easily for each breaks before they are pushed live. This setup, without any doubt, makes developer life easier. One last thing. We can also discuss a use case that is not always thought about when looking at our product. This customer backend is using Contentful. As it's a headless SaaS offering, they need somewhere to host their frontend, which they did at Platform.sh. The Gatsby frontend fetches its content from the SaaS backend and serves it to their users. The developers can leverage Platform.sh features to test and deploy the frontend while the backend is handled by a SaaS provider. Now, this was our customers and the way they run things with us. But we at Platform.sh, we also are using our own platform, and we've came with some examples today. Our very console, the one you use daily, is hosted on the same product you are using. As you can see, with our 71 active environments, we make use of the multiple environments and cloning feature quite a lot, as any change is thoroughly tested and reviewed being pushed live. We are even using the composable image features as we need some custom items within the deployed image. This use case echoes the previous customer example as no data are stored in the console and everything is fetched through API calls to our backend. This example is also interesting. All our customer authentication requests are going through the presented project. That is, as you can see, also deployed on our PaaS. As always, and because any change can have a massive impact on our customer, we use the environment cloning features to run all our tests before pushing live any changes that are done. We also like to have fun, and we found this use case very interesting to be presented. This is a bot we have on Slack that informs about the teammates that are out of office for the day. This bot's backend is running on Platform.sh and with Python. It fetches the data of who's out today from Bamboo HR API for the bot to present on Slack. To get back to the more serious stuff, our API proxy is a stateless application deployed on multiple regions from a very single Git repository. We configured the CDN in front of it to fail over automatically to another region if the current projection becomes unavailable. This API proxy handles all the API calls that are being done against our product. Another use case that is a bit more interesting is also what we provide to our white label partners, which is called a vendor box. They get access to their own CLI, own console, sign-on, and so on, that they can customize to fit their brand image or their needs. This is deployed on a Platform.sh project as well for each of our partners. As you can see, this is a microservice approach with a lot of workers. Finally, even our data warehouse is hosted on Platform.sh. It connects to Google BigQuery and other different sources to provide us with useful data and nice dashboards to understand how our product is used and feed us data on how we can improve. I hope this presentation was helpful to understand use cases of usage of our platform that you may never have thought about before or different ways of approaching them. Talk to you soon about your project and don't hesitate to reach us to provide any feedback that you may have.